Okay, so this week we're gonna get into Unit 6, Part 1. Unit 6 is about Total Productive Maintenance, thus TPM. So TPM is just a philosophy, it's a way of thinking, and we can call it a culture. So TPM is not a program, okay, it's very different. It's just a wide equipment and resource management strategy. So if you don't remember this, you can just remember TPM is just a strategy, okay, for overall quality and productivity improvement. I usually remember TPM as a strategy for improvement, and we need all of this in this strategy. So your teamwork, education training, communication, ownership, and empowerment. So to understand and implement TPM is to understand the culture of change. So TPM is involved with how to avoid a crisis, okay, in the first place. So you don't want to go into the direction of crisis. You want to go to the success by doing a strategy. So the implication of TPM or total productive maintenance is that every part of an organization gotta work, okay, towards increases in productivity, and that's the only way to get TPM success. So the TPM implementation and practice, the cornerstone is total participation. You have to get involved, okay? Involvement of all personnel, especially the operating personnel. So the operators must have an active role, okay, in the basic maintenance of the equipment, which represents a shift to autonomous and self-directed maintenance. Here I just trying to tell you, in order for the implementation of TPM or this strategy to be successful in your facility, you have to make everybody get involved. So most of the time, employees, they're afraid of change. They don't want change, and they don't believe that change is going to take place. Okay, resistant to it. So the level of success a company has experienced with such ventures in the past is a good indicator of future performance. So the concept of change also tends to be unsettling again to most people. Dr. Damon says he was a quality guru, so his legacy, we're gonna take a look at it. So according to him, management must create a statement of purpose and then share it with all the employees. And he advocated eliminating fear, create trust, and developing an environment that fosters innovation and empowerment, accomplished by clear, open, and honest communication. So in terms of TPM, Damon's legacy is the same. You have to communicate the philosophy and purpose of TPM, okay, through open and clear communication, and drive out the fear of all concerned individuals. You have to make them very comfortable with this strategy so they will perform it. Unions are always there for the workforce, so you definitely need to know this organization. So TPM requires some maintenance and upkeep activities to move from the traditional maintenance department to the operator. So in a traditional union shop, this may appear to be a violation of job description and classifications, and these things are what union is going to oppose. So if the purpose of TPM is to reduce the number of maintenance department employees, then the strategy is doomed to failure from the start because union is going to protect the employment. So whether the plant is a union shop or not. So you have to be very careful of your purpose when you implement TPM, not to get a clash with unions. So you have to make unions understand the true purpose of TPM. and that is to improve the quality and productivity by increasing uptime and achieving zero defects with the aid and direct involvement of the operator. So TPM implementation can and has been successful in union plants like AT&T, DuPont, Ford, Motorola, and your Texas Instruments, which is your TIs. So this is your TI 89, and this is the calculator. I recommend you to have it. Um, as a university student, you need one of this. So both the management and the union must realize that their adversarial relations of the past must give way to a spirit of mutual respect and cooperation for the benefit of the company and all its employees. I just trying to tell you that you have to work with unions for your TPM to be successful in your company. So the company must make union understand the purpose is not okay to shift maintenance function from the department to the operators to reduce the number of maintenance employees at all. And then TPM can actually improve the overall quality of work life by improving the safety of the equipment and the workplace. So a primary concern of any union by creating a cleaner environment and by upgrading the working condition. So you have to definitely make union understand that we are doing the TPM to improve the overall quality of work life. Okay, and we're doing that by improving the safety of the equipment and the workplace, and that safety, okay, of the equipment and workplace is the primary concern of any union. So you have to make them understand that fact, not this one. So union leaders and the membership should be involved in the early stages of planning for TPM, and institute a well-planned TPM education and training program is really good for this strategy. Okay, this is just a short video, and let's take a break here and you can watch the 4 principles of TPM. Okay, that was a quick break. I'm back. Okay, so for the total productive maintenance, you really need a clear plan and a roadmap. So we cannot know where we're going or that we have arrived if we do not know where we're coming from. So you definitely need to know the route and then the direction. So the introduction of promoting TPM is nothing but after management has made their decision or implementing TPM, then they involve the union leaders to make sure everything is good to go, and then introduce the TPM goals and objectives to the rest of the employees. So that's pretty much the procedure of implementation of TPM, of course, in its infancy phase. And then we come into communication period. So what we're doing here is we're communicating the goals and objectives, of the TPM to the employees. So what you do, you take them, as they have designed a strategy, and then you talk to the employees about it. So TPM aims to eliminate unplanned downtime. We don't want that. We also want to achieve the zero defects in the production. Okay, we don't want defect. We want to eliminate this. So due to equipment malfunction, especially this in the maintenance category. So it also eradicates loss of equipment speed. So therefore, TPM is we're guarding the system from malfunctioning. Okay, we're going to protect the system so it won't malfunction. If the system is up and running, you won't get a lot of defects or downtime. So that's what we're trying to do in TPM from the maintenance perspective. Okay, the next phase is with assessing the current conditions. So usually go in there and then you're gonna assess the current equipment status. Okay, I'll show you the table 6 one. It's just an example of your equipment condition analysis. So you analyze and then come up with the current equipment stats. So current status can be assessed. So what do we do? Assess by reviewing the existing and past work orders. So this is your table 6.2, and here you can see the equipment condition analysis. So if you take a look at the first row, this is your analysis, and it's going with a rating scale: poor, fair, good, excellent. Okay, go all the way down. So you take a look at the condition for poor. Rating scale is below all standard, very difficult to operate and unreliable. And they have very low OEE. I'll tell you what that is later on. And then decimal hole tolerance. So no improvements done, unsafe to operate. This is very bad. And very high scrap rate, okay, and no PM. Possible actions that we can do requires immediate attention, okay? Why? Because this here, when you look at it, unsafe to operate. That is definitely pushing us for this immediate attention. Scrap, rebuild, start PM, improve function and safety. Okay, clean up and then repaint and then hide. So everything you're going to do these actions, if you see this type of condition from your analysis, rating as poor. Okay. All right. Then the next phase is assessing the current maintenance effectiveness. So the effectiveness of current maintenance program is measured by looking at current maintenance productivity. So in order for us to be able to study the effectiveness, okay, we're going to look at the productivity, and I'll show you in table 6.2. So the current level of organization's maintenance productivity, we can calculate, okay, by multiplying three things. The very first one is utilization, second is the methods, and the third is the performance. And we will multiply these three factors and you will get the productivity. So here is your 6.2, and we're seeing the current maintenance productivity. So you can see in percentages. So if you take a look at the first one for 40%, okay, maintenance productivity, we have three things going on: utilization, multiplied by methods, and performance. So utilization is nothing but noticeable job delays and idle time is there. Informal material parts control, frequent stock outs, no record of use time, no skill coordination, no work planning, historical data not used for scheduling, and many old or outdated drawings, and no scheduling. So methods, no job instruction, no industry engineering effort apparent, no standards, frequent rework required, so that's not very good. All equipment you're using, all equipment's not very good. Methods and planning work left to the workers. Work considered too difficult, okay, to predefine, and very few one-man jobs are there. So performance, when you look at it for 40%, frequent revisions of job is necessary. So many interrupted jobs, low workload level, occasional good effort noticeable, no reporting system used, no supervisory training, low skill level, and poor attitude. So all these things are giving you about 40% of your productivity. So you can read from 50 all the way up. Okay, when you take a look at coming to 90 to 100%, you're going to see the utilization methods and performance are different from that of 40% in the previous slide. So let's take a look at it. So at 90 to 100% productivity, practically no delays, required materials always available there for you. All plannable jobs are pre-planned, okay? So you already know what jobs you're going to be doing. Management controls pinpoint the problem areas. You also understand the problem areas. Sophisticated planning and dispatching of work, so technology has been used here. Methods, tools, and equipment taught. Standard tools and procedures are available. Some volume of repetitive work. High skill level of workers. all methods are totally pre-planned. And performance, when you look at it, sound working incentive plans there, well-trained supervisors are there to help you, no recent labor trouble or strikes, good backlog of work, okay, not a lot piling up for you to do, and pride of workmanship and low labor turnover. So therefore, you have 90 to 100% productivity. Okay, this is your first calculation. It's really easy. We're going to calculate productivity. For that, you need utilization, methods, and performance. Productivity is again in percentage. So there's only two numbers for percentage, okay? They're back to back your decimals, and you have to know, and you should know by now, how to change your decimal into percentage, okay? Now we have 65% utilization, 50% methods, and 70% performance. Okay, so that's how a company is rated. Now, in order for us to calculate the productivity of such company, we're going to multiply that three factors. So we multiply that and we get 0.24. Change that decimal into percent. So first and second decimal. So we have in the tens, okay, so 24%. Okay, I told you I'm going to tell you what OEE is. So your OEE is nothing but your overall equipment effectiveness. So a quantitative, more reliable approach to assessing the current condition of the equipment totally entails observing the equipment over a period, that's the time, and calculating its overall equipment effectiveness. Okay, that's just a formal definition. So all you have to know is we can calculate OEE by multiplying these three factors: your availability, your efficiency, and your quality. Okay, now you have two equations. I'll make sure you study. So this next week quiz, you should be able to differentiate these equations, and please memorize. If you cannot be able to remember by reading, make sure you repeat your readings and I'll try to get that into your head. Okay, availability is also referred to as equipment utilization. So it's a ratio of actual operation time, okay, and the net available time. Every ratio is nothing but it's just a division, okay, so operation time over net available time. So you have net available time and we're looking at the operation time out of it. So net available time is the total available time less any planned downtime such as breaks or planned preventive maintenance activities, your PM, okay? So you're going to subtract all of that total from the total available time. So there you get your net. Therefore, if you have like 1.5 hours of planned downtime, the downtimes are, again, if I ask you what is a downtime, you should know by now: breaks, preventive maintenance, your PM, meetings, and so on. A schedule doing an 8-hour shift, okay? And that's your total available time. Availability, we can calculate availability by dividing operation time over net available time. Okay, so net available time is your total available time minus planned downtime. So net available time equal to 8 hours is your total available time minus 1.5 is your planned downtime. Is equal to 8 minus 1.5 will give you 6.5 hours, and that's your net available time. So if you have like 0.5 hour of unplanned downtime, you want to add that to your planned downtime and take it out from 8 hour. Then you will get your operation time this time. Okay, and the operation time is 6 hours. So this is 2 minus from 8, so you will get 6. So therefore, availability is equal to the 6 hour, your operation time, divided by 6.5 hour net available time. So we will get 6 divided by 6.5 is going to give you 0.923, which is 92.3%. Okay, this is for part 1.